All right, I think it worked. I think there's nobody to verify if you transmit on YouTube and there's nobody to interact with, or is there really a TCP session active? I wonder. Hi, everyone. I'm Bill Hurd. Unfortunately, Ben and our guest hosts are missing in action today, so this is going to be a short one. I actually don't do well just speaking by myself, as I already have voices in my head, and it becomes hard for me to tell which voices are real and which ones are the YouTube generated ones. So what we might do in the future to prevent this is maybe get some of you all ready in case y'all had Commodore stories. If anybody had a Commodore story and you have a web camera and a microphone and you want to join us right now, I'll send an invite. I'll put the invite right in the chat window here and you can join me, but you got to do it quick because I'm only going to broadcast for about 5 minutes if Ben's not here. So tell stories. We always love your stories. I've told all my stories. You've heard them all. There is a book out of stories. Hang on. I know. Either you think I plug this all the time or that I forget to plug it all the time. I think Margaret thinks I forget to plug it. I don't have any good stories. I have a cool piece of test equipment though. I'm going to show you. I want to thank Matt Liberty over at JewelScope. JewelScope.com sent me a piece of test equipment called a JewelScope. And it allows me, maybe I can show you a picture here. That looks like noise, but what's interesting about this noise is it's very high gain noise, right? And what this JewelScope can do that an oscilloscope can't necessarily do easily is jump ranges. There's auto correction going on inside these things. And so suddenly now, and hopefully you can see this, this reads out in current, so there's a current sense resistor going on here. It reads out in voltage, but then it does the math for you for watts. Easy math to do unless you're starting to deal with irregular wave shapes and curves and whatnot. But look here on the right, it actually reads out in wattage in the min watts and max watts. You can see my load here is about 3.8 watts. This is really cool. You want to know what that is in joules? A joule is a 1 watt per second. And that reads out here too. So let me show you a dynamic load and see if we can get a prettier picture going. Oh, it's upset now. Yeah, I'm checking some batteries. I'm doing all kinds of things. But what I can do here is zoom in. And this is one of the cooler features of this. And here's where you can see that it's stored the information in high def, even though you get that nice big long picture. So unlike an oscilloscope, you don't need to trigger that event that catches once, because you can jump out to the main event and catch it and then zoom in. A DSO will do that, but it was problematic for me to get some current measurements and then zoom in on them. And I could talk later. I need to have Alan Wolke back on the show, and we'll talk more about some of the math you can do in the front end of your DSO, your digital scope. So besides LC, any stories, equipment about you guys wanted to make out? Oh, I do have a story. Thank you for that. Who asked for that? Mr. Landfill. So back in the day, that's what you wanted to hear, right? Back in the day, we liked Hitchhiker's Guide to the Galaxy. It was like this, wow, what kind of person writes this, right? I remember when the first book came out and we were waiting for the second book by Douglas Adams, who's no longer with us, unfortunately. Or I try and have him on the show. But Douglas Adams wrote this wonderful series called Hitchhiker's Guide to the Galaxy. And in there, they had there was the Encyclopedia Galactica, but the Hitchhiker's Guide had "Don't Panic" written on the cover. You may have seen what's his name did a SpaceX shot or something with "Don't Panic" on there. But we were enamored, especially Terry Ryan, the guy that wrote BASIC for millions of people and claims to not remember having done it. He wanted to make a PIM. And when I say he, we did too, but Terry was kind of the one we pushed out in front, the star of the show for the PIM, the Personal Information Manager. And what we wanted to do was something, I don't know, about that size, right? Something you can hold in your hand, maybe not as tall. But there was a new technology out. I mean, we had LCD, we had the Commodore LCD. There's new technology out. It was called a CD-ROM. And we were like, oh my God, if we can put a CD-ROM in a portable computer and have everything from, oh, hey, we do have somebody showing up here. Let's
Oh, what the heck's going on? It's one of those mornings.
Oh, Ben has joined us. I was just about to finish the story.
No, I guess we need to get the link to Eli as well.
Yeah, I'm imagining. So if I finish my story real quick, the PIM became this personal information, and then it went nowhere. Then Commodore dumped its management, and we all went our separate ways. But years later, I found a 3-ring binder, and I flipped the label around, and right on there it said PIM, Personal Information Manager. So it was my proof that we had had this this night dream, this heat dream, 40 years ago, 35 years ago, about a portable computer that could look up everything from architecture, ballistics to zoology. That's how we sold it. We figured it'd be like an encyclopedia that you could carry around. And this is in the days when you still bought encyclopedias. There was no internet. It's hard to imagine that these days. But so, yep, Ben's come and gone. I'm assuming Ben will come back. So we'll wait. Anybody else have a story you want to hear? I don't know what stories to tell. You all heard about CES looming in the distance and pulling in and seeing a billboard. Imagine being a 25-year-old kid pulling into Las Vegas, and there's your computer you've bled all over on this big, huge billboard. And of course, the billboard's wrong, right? It's got a piece of information in there that's expandable to 512K, when my boss had nixed the expandable to 512K part of it. So we had to go back, and after the CES show, invent the REU RAM expansion unit, which we gave to Frank Palea to do. So the REU, which it was January, and Fred Bowen and Terry Ryan managed to get commands into BASIC in time for production to support get and put for the REU, the DMA engine, direct memory access. And the reason direct memory access was so important is normally a 6502 microprocessor picks something up, figures out where to put it, and puts it there, and then comes back, increments program loop, and gets the next one. And this can take 10 microseconds to do. But direct memory access is where you point at it. You say, you move your contents there. Don't tell me about it. Just freaking do it. And the DMA takes over. And it was so fast that it would animate the screen. So Headley Davis wrote a spinning globe demo that we showed at the Chicago CES in '85. And it was just 36 or 12 or some 24, something like that, pictures of a globe spinning, and he's DMAing them to the display so fast it was animation. And, the only animation that existed at that time was the bouncing ball of the Amiga, right? Not the only, but you know what I mean. So, oh, wait, we've got other people. Let's add them to the stream here. And, whoa, hey, there we are. I am good. I am done.
Sorry. I'm so sorry to leave you hanging there, Bill. Thanks for starting.
Not a problem. Hello, Eli. How are you?
I had one of those mornings where I had to go set up a new bank account. And the earliest time I could get an appointment was 9:30. And I'm like, surely it won't take more than half an hour to set up a bank account.
No. Yeah, it's like buying a car in less than 2 hours. No, it's not happening.
Thanks to everything really slowly and methodically.
Well,
no offense if anyone here is a banker. Actually, there's good reasons for that. You're dealing with people's money, so that's kind of the right approach. So I get it. I understand. It's just when you've got places to be, it's like really stressful.
No, we have a whole meme that existed probably before you came to the States about bankers' hours because they only work from 10 to 2.
Oh, they say that in Australia too.
Do they? Okay.
And
about our
also
banks or
because-
your banks?
Also because banks get special public holidays that other people don't get
Right.
in Australia.
Right.
So
well, you're here. Take it over. Tell us about Mr. Hughes and why you asked him on and just what all we're going to talk about today.
it's so great to see you. It's been too long. How are you?
You too, Ben. I'm doing good. Assuming you guys can hear me?
Yes.
Oh, yeah. You sound and look good.
Thank you for joining us today.
Yes.
I just never
volume
know if
could
I'm
be-
like, I'm sorry. I just never know if I'm speaking into the void and no one else can hear me. So I
well, you are, but that doesn't change the fact that we can hear you. So
No, it's all good.
yeah.
So, yeah, I actually have been meaning to ask you to join us for a long time, and finally thought, I just need to do it. And it was kind of short notice, so I really appreciate you being enthusiastically accepting.
Hey, no problem. Yeah.
But you're just such a great engineer and so experienced and done some really interesting things. Some I know are proprietary, some you can talk about. And I just thought it'd be great to catch up. And you show up occasionally on our Discord as well.
I do. It's hit or miss.
And you're a bit younger than me, I think. But you're kind of in the same age group that, for me at least, like we grew up with a 6502 and other things. So, and you got a lot of cool ways of wrapping that into what you do now, which is you are a true full stack developer, right? And this is controversial because there's a lot of people who watch our streams who are primarily software developers, and probably in their day job, some of them are quote unquote full stack.
Mm-hmm.
They're doing what the software world considers full stack, but
7 layers of OSI. Yes.
Yeah, but we kind of feel like there's more to it than all of that. So just if you would share with us a bit about yourself, your background, because you kind of, I'll just let you take it.
Yeah, go for it.
Yeah.
I probably took a little bit different path than some of the traditional engineering, partially just because of how I grew up, and you're always kind of influenced by environment and whatnot. But for as long as I can remember, and especially being young in the 80s, video games. So when it wasn't Voltron and Go Speed Racer, it was playing the Atari. And I specifically remember my brother and I seeing the first advertisement for the Nintendo Entertainment System. And it was, there was nothing more exciting than when we got that, on the farm. And boy, that would have started in for me pretty young. That would have been 1985 or 86, playing Mario Brothers. But yeah, we were full, that's all we did, or all actually I did. But really there was an inflection point in 7th grade. So I grew up in a really rural community in northwestern Pennsylvania. So technology was the last place to reach where we were at.
Right. I'm from Indiana, and it was the same thing. There was TV sets was all we had.
Yeah. And so the Nintendo really, I say, was my first computer, because I to this, once my mind, I was opened up to thinking about computing. But in 7th grade, there was a course in our middle school called computer literacy, to bring technology to us Hicks, because we grew up in an area where doing well meant you got in the logging industry, or you got in lumber and woodworking, or and that's one of my other passions kind of came from that. But computer literacy was one half was you sat on Apple IIe's, and at the time you learned how to print. You learn a little bit. There was a database application that we learned, very basic database with basic queries, and I remember a very rudimentary spreadsheet. But the second half was you learned how to program in BASIC. And so once literally, and I sent Ben a presentation I did for Altium Live.
Did you want me to open that up? I've got it right here.
Yeah, and there was like one thing I remember once when we were in really learning about it, was the teacher giving us printouts saying, just type this in and see some effect happen. In once in BASIC, there was a command just to put a line on the screen. It like snapped instantly. I'm like, wait a minute, that's how this happens. And I got hooked to the point I would stay after school. The teacher gave me the manual, and just reading through the technical reference manual, because like in rural Pennsylvania, there wasn't much else to do, especially in the wintertime. It mentioned the 6502 processor in this thing called peek and poke, right, to hit memory. But there was something else very, very, serendipitous. My reading at the time with my buddy Adrian and I was Nintendo Power. Like we'd get it in the mail, and it actually had a little discussion of the 6502 processor in the Nintendo. And right there, that was the connection that needed to be made. Was that the thing that powered the gaming system powered that computer? That means I can make that thing do anything. And that's where, oh yeah, like I still, yeah.
Right. So this is your first.
I use the word empowerment because for me, whatever genes or neurons I had firing, I made the connection. And at that point, yeah, that was the equivalency. And that's why I say the Nintendo was my first computer, because then I got to ask questions about what are these ports on the bottom and what are these other things. Yeah. The unfortunate part is, and to Bill's point about DMA, like when I joined, is I did have a question: is why was my stuff so crappy that I would write on the screen my animations, but the Nintendo was fast. I mean, it could it had animations, my things flickered. In part of that was the manual of the peek, poke, and call, and there was specifically a peek or a poke that you could like blit a graphic defined in memory and not flicker on the screen. And that's how, and the Apple II didn't really have that great of graphics hardware, but that's where I discovered there was this other thing called assembly language. Right. And if I was gonna program those games, I needed to know that. And it's unfortunate, especially in this full stack world, of people look at things like assembly like it's hard. For me, no, it's easy. Those instructions do one thing only, and you just chain them up. Like it's actually, like
in that sense much easier. It's just when people say something's hard, I think what they really mean is, I don't know if I want to take the time. But the truth is, if you're a good assembly language programmer, I mean, you get more efficiency out of high-level languages, right, normally. But if you're a good assembly language programmer and you have some discipline around that, you still do things in a modular fashion, just like you do with high-level languages, and it becomes efficient. You write code so it's relocatable.
Oh, right? Yeah. And one thing, if you've never had to write assembly language, that you learn pretty quick is most of these assemblers have a macro system, and you almost start inventing basic ABIs and way of calling functions, and you can do some pretty amazing things. And the other thing is later on, I got into Motorola 6500 or 5600 DSP, and it actually had a whole assembly language system that wasn't that was really interesting. Oh yeah, that was the other thing too, is post 7th grade, there wasn't any other coursework. And I remember my mom, when I go visit her in Pittsburgh, she would take me to these I was bored out of my gourd. I would go to these flea markets and walk around, but I saw this book.
Like this?
Yeah, it literally looked like that in a giant shopping mall. And I saw that book by Rodney Zacks, it says 6502, and I begged my mom. She was
Yeah.
like, "Oh no, honey, that's for college." I extracted it. I still have it. Like I keep it. This is the book.
Oh,
It's
yeah.
traveled with me. And that summer at my mom's, I did not have a computer to use, but I had a piece of paper and I would write the programs. I would just,
Yep.
it had basic, algorithms, in the book, but I would dream about what that piece of code would do. And so for me, in my context comes from physically writing down the code on a piece of paper and understanding it's like a machine. And that's why I say assembly language to me is simple, because it doesn't do much, right? You'd have to chain a lot, but at the same time, like, to do complicated things, you got to chain it up. But yeah, this is one thing. I first showed this slide at a conference in Guatemala of a buddy of mine, Brandon Clark, who's a colleague I met at State College. We were talking about Terminator from the 80s. Well, when Terminator's heads-up display comes up,
Right.
when he kind of first pops in.
If you're an O2 programmer, you
this
spot it
pops
right
up.
away.
So
What?
the T8000 is powered by like the 6502. So it can definitely do anything. It traveled time. And
Do you know I showed that film clip to Chuck Peddle, father of the 6502. I showed him that and Bender's going kill all humans and everything. So I asked him, I'm like, Chuck, are you really an evil genius bent on world domination? And he took it and he spit it right back at me without blinking an eye. He's like, oh, we're in so much medical equipment. We save lives. And so my answer was, oh, so you've saved more lives than you've taken. And he's like, yes.
I just think that's an anecdote of, and this is part of this whole this zeitgeist, that I've had offline discussions of like, what makes the 6502 kind of special. But if you were to, you can't separate, in my opinion, you absolutely can. It's inseparable from the cultural activities that were happening at the time.
Yeah,
like I don't. You can't take another there, because there are newer processors that are much cooler and better, but they will never have that same feeling. And I think it's because of the cultural impact. But anyway, I in a lot of presentations, when I talk about who I am, I'm like, when I start with the NES, and I always bring because the Terminator was like in the 80s that was the movie.
Yeah, absolutely.
That was.
So what happened is, and you can actually page forward, Ben, is like for me, moving forward in high school, there were no programming classes, so I disconnected. I mean, I was the worst student you could possibly imagine, just because I didn't care. Like, right? So I just
that
kind
was
of
me.
Yeah, and I started kind of going down that path. But one thing I did discover, and the one thing my father did for me, he took me to a music store in Williamsport, Pennsylvania. He serviced old Hammond organs there. I blew off a week of school. He told me, hey, you're going to hang out here. You're blowing off school anyway, so you're going to hang out with me in the store. And there was an organ that had little lights above the keys that I learned how to play Chariots of Fire and Invention Number 13 by Johann Sebastian Bach.
Oh,
that's
come on.
What kicked that was another thing that kicked on of like, this machine, I can press buttons and get like output. And so I got super into the keyboards, and what they had downstairs in the music store, they were a big dealer of Ensoniq. In those machines,
mom had that exact. My mom had the 88 key SQ2.
And at the time, the ASR10, the VFX, the TS. Ensoniq had some really interesting technology, and it opened up like this other world. And it turned out that world was just as germane to computing as everything else. So, I got really good at keyboard, but back to the guitar, and you saw the Carvin, Kiesel, is no one wanted a keyboard player in their bands, even though I consider myself pretty good. So I learned guitar because, this was like early 90s. 80s metal was still a thing. 80s shred was still a thing, and grunge was a thing. So that's when I got really into guitar, and that's when I found the Pennsylvania College of Technology, which was really a lifeline for me because I did so poorly in high school. I kind of caught up in my senior year because I knew I had to do something. Penn College was a tech school. They had a 4-year program in electronics. And as soon as I saw that, I was originally going to go for something like programming or an IT thing. But once I saw those electronics instructors, I thought it was boring organ service. They showed me, no, we have computers connected to robots. We have circuits connected to the ISA bus. I was like, oh my God, this is exactly what I want. I want to write code that turns those things on.
Turns on and off. Yeah.
And it was literally like I said, it was a lifeline. It changed how I saw the world.
Yeah.
100%. So
yeah, now the Ensoniq was done by the guys that did the Commodore 64, right?
Yeah, and that's actually, I mentioned to Ben, I was texting last night. I kind of knew that, but I never really got the whole story. And that's why I was interested on your perspective.
Well, we had Al Charpentier one week back in March. And
I'll have to look
he
that.
stayed at Ensoniq for quite some time, didn't he? Did he go to Ensoniq?
No, he started in Sonic. Him and Bob Yanis started in Sonic. They got into not just the keyboards, but they ended up selling to Turtle Beach, or they so they had high quality sound cards, and then they did a divergent effort that Albert calls a mistake, but they tried to get into hearing aids. But it is and it's staffed half full of Commodore people. So even the way the Ensoniq schematic was drawn, it was drawn by the same girl that drew the C64 schematic. So it looked the same as you read from left to right on it.
And those keyboards are like, I'm a guitarist as well and never learnt to play keys. But I have an appreciation for what's in them. Keyboards, particularly synthesizers, have so much computing power. It's awesome.
What's interesting,
you go back to the synths of the 80s,
right?
And
some of those, where I got my start.
Some of those have more computing power in them that they'll have multiple CPUs, and they'll have more computing power in them than an NES console for the same year. And I never really understood back then as a kid why some of these instruments were so darned expensive. But if you ever look at the service manuals for some of those earlier Kurzweils and Ensoniqs and Rolands, you realize there's a lot of parts which would have been very expensive in their time inside.
So the other thing I was going to mention, and part of the reason, and I discovered this, and if you advance, I think a frame or two in the, is that I kind of took apart one of my Ensoniq keyboards, and I kind of started college, and Penn College started with you still took your calculus and physics, but they started you right away in labs and microprocessor labs. And I got the bravery to take apart my super expensive SQ2 and see what was inside. And that's when I discovered, that's where I learned Protel. Anyone who knows the original Protel, it was very advanced for the time, being a Windows-based tool, but it had this bomb that came up. It would crash all the time, and it showed you like a little bomb.
It had a cherry bomb icon, and Matt
and
Schwager and others begged Nick Martin to remove that from the dialogue, and he refused until probably Protel 98 when it finally went away.
Yeah, well, tell Matt, I still remember. Like
everyone who was using it back then remembers the cherry bomb.
But when I took apart that SQ2,
there it is. This
is there it is.
I was looking for. Did you have shots of inside this at all? Or?
I don't, because when I put this presentation together, I was kind of under duress, so I just did the minimal effort.
The best you could. Yeah.
But what's inside there, and it might be on the next slide, is was the Motorola 68000.
Oh yes, come on.
So, and it just so happened that the microprocessor lab that we were going to have one semester was all taught with the HC11, and my advisor, he was super big into. He was like a wizard, with it all. And I showed him. I got the schematic for the Ensoniq because you could just get them. And it had multiple of them with some sound chips.
That was back in the days when all musical equipment you could just pay the photocopying fees, and the local distributor or service center or the local office of the manufacturer would just give you a copy of the whole service manual, schematics, and everything, because the music industry traditionally demanded everything has to be serviceable on the road, which kind of makes sense. If you have an SQ2 and you're on, and those actually were the chips, the Ensoniq chips are fantastic, but the electromechanical build of the SQ2 is unreliable. My mum ended up replacing it with a Roland.
Mm-hmm.
And the sole reason is she went through 2 SQ2s with reliability problems after it had a full-on attaché road case and everything to protect it.
Yeah, it didn't matter.
But she would take it to different places. She would play at retirement homes at the time, entertain old folks, and occasionally it would come back and a section of keys would stop working or something,
Yeah, so that's the interesting part about and why the music tie-in was so interesting to me. And even now, and I kind of chuckle a little bit about open source hardware and open source software. I'm like, hardware people have been doing this nearly since the beginning, of publishing schematics and whatnot. And you could really dive in. But I remember the manual, and I through a connection at the music store, I got to someone in Sonic Dista, and I can't remember who it was telling me about what they called their transwave technology, which was essentially a fancy DMA that you could have multiple wavetables that you could apply, amplitude envelopes to, and then interpolate in between the wavetables, so you could create some pretty complicated, sounds. And I didn't have some of the other Ensoniq gear. Even now, if you go to eBay and look up for an ASR 10 sampler, I'm still blown away the prices those things are getting.
Oh my gosh, yeah.
That built in all that technology. But for me, it gave me a way as a launching pad to get into signal processing, because the original Mirage sampler, the gentleman told me that they used a weird 8-bit floating point, and I learned about, there's other floating point technologies out there.
8-bit floating point.
Yeah, it was.
Yeah, we did 8-bit floating point at the instrumentation company I worked at. Yeah.
Really?
And,
yeah. Oh, yeah. Yeah. We performed some 10 operations in a quarter second. And that was just amazingly fast. We couldn't do CMOS based processors because they would take 2 seconds to do what the NMOS processor could do in quarter second. So yeah, full floating.
Tying back to the video game, the Sega Genesis that was built on 68,000, it was just another piece for me. I was still super in the video games, that these same chips are everywhere. And it just kind of really cemented that, there's no magic here. Anyone who wants to can kind of tear this stuff apart and get at any level.
I'm curious if anyone on the Discord or on the stream has a Genesis. I'm sure there's some out there.
Oh yeah, it's kind of interesting because Nintendo either through some sort of licensing arrangement now still publishes the games on their new systems, and you can actually get this Genesis controller that will synchronize to the new Nintendo system. So it's still very much a well followed system, but yeah, so the musical thing really tied a lot into it. And then because I was still into guitar, my senior year, we had a course in digital signal processing, which most people, it's really hard to relate that to everyday life. And especially the math gets tough. But for me, it just so happened that Line 6 released their kidney bean, the pod, the original pod. And
was it that long ago?
It was that long ago because I was at the local store and they were showing it off, and because they were a big Marshall dealer and they had stacks and stacks of of Marshall, and they had
Yeah.
this little pod next to them, and everyone was like blown away that this thing in the original pod had its quirks, but it sounded really good at the time, and I was like, well, what in the world is in that thing that you could replace these Marshall full stacks or your Fender twin reverb?
Oh yeah.
In that to
Impulse
this day,
responses.
to this day, I still, when I think about projects, I think in terms of making cool stuff for the guitar because it ties
Well,
in
that's
real.
a project. That's a project. One of your designs that I actually made, and
Yeah,
called the Monkey Jam, which was
Yeah.
really cool.
yeah, all those.
You should tell us about that real quick. I'll see if I can go.
Well, once again, that was, I actually have one. Let me see.
Okay.
Give me
You
one
probably
second.
have one closer within reach. I'll see if I
So-
can.
Yeah, I'll hold it up. It's this little Arduino compatible little board with knobs, and it has like a real codec on it, but it was designed. I don't know if I can pull this thing apart without.
That's on a Freescale FRDM KL25Z.
Yeah,
right?
an older Freescale board. So,
So that's an ARM. It's an ARM Cortex
M. It's
M3.
M4. It's actually an M4, but
Okay, so it has hardware multiply divide. That's what makes it possible.
yeah. So what was interesting too, and this was kind of a trick I learned early on, is that getting other people to pay for what I like to do, and being sneaky about it. So
that's exactly what we're all trying to do.
So
with life,
Freescale was
That's
the first company to release the Cortex M4 in their Kineta series. And the initial ones did not have the floating point core as fixed point. And someone from the university program said, hey, do you want to write some articles and do some projects on our Freedom platform? And I said, yes, I will accept your money, and I'm going to build some guitar electronics. The net payment per hour was probably pretty horrible, but, it launched into a lot of other stuff. And I said, here's a cool project. You learn how to hook up a real codec, analog digital converter, 24-bit. We're going to have some real-time signal processing. It's still limited enough. You can't, you've got to pay attention to how you're writing your code. So it turned out to be a very practical project because
right.
The challenge in the EE world, and especially things with DSP, they're taught generally from what we call the black book. It's this classic DSP text that connecting that mathematics to real life, I can guarantee you, because I've taught at Penn State, very few students could say, I want you to implement this algorithm in real time on a chip with no help from MATLAB. Translate that book into code. It's hard to do because it's not taught that way. And it turns out, once again, I figured it out by writing it down on a piece of paper of saying, this cannot be magic. It has to be, you add these things and multiply, and you run it through the chip.
That's it. That was my final project for my last year in engineering research. So the 4-year programs in Australia, most of the final year, which is where I guess where you can qualify for honors, right? And you do a capstone project. So people do that here too. And I was doing speech synthesis in a soft IP core CPU in an FPGA. And that was such a great experience. It was really stressful, but it forces you, if you're gonna implement some biquads or whatever in an actual chip, and any ARM microcontroller is fast enough to do decent audio DSP these days. The only real limitation is how much memory do you have if you want to make nice long reverbs or have really high definition impulse responses. You need a very long impulse response filter, right? So that takes a lot of memory and a lot of multiply accumulate cycles. So that's your only real limitation these days. But it's such a good experience implementing that stuff.
So yeah, and for me, I took the pod apart and found the DSP 56000 series, and And it's what we used in our class for implementing for writing code. And what's interesting, that series, the assembler that comes, there it is.
This is one of my cherished. Why don't these cameras focus?
Focus,
So irritating. But this is our 56303 development board, eval board from Motorola back, when it was still Motorola. And I used to use this to do demos of the tasking C++ DSP56K toolchain. I didn't do many, but I did a few. And there was a cool little app we could put audio into one of the jacks, and it would display an FFT or an oscilloscope. Anyway, the 56Ks are still used like NXP. It's like they're trying to have them replaced, but you can still buy some multi-core versions of it because there's still companies like Dolby or others that are
they're
developing
everywhere.
products. Like they just want to keep using them because they've got all this code. Why would you spend so much time rewriting everything when you've really dialed it in and it's optimized?
Oh, and it's dialed in. But one of the assemblers, I remember that Analog Device. Well, I should say this wasn't Motorola, but Analog Devices had a competing part in the family, the ADSP series. Their assembly language mnemonics were not written like how Intel or Motorola did it. If you had something like a move instruction, move into accumulator, you didn't write like move, A comma
or something. Yeah.
They literally said their assembler accepted A equals 5. And it would accept fixed point notation that you could take in and tell it, how many binary digits were on the left or right of the decimal point. And you could look at the programs, and their conditional codes were literally written as if statements, if accumulator or carry flag or whatever. And
I like that. I think more instruction sets should be developed that way.
And there's no reason you can't, because it just maps definitely to machine code. But that was kind of how, and to this day, that's how I think about when I write code. I think about it, and just kind of comes from this DSP world. But yeah, and for me, it was just through college, and my senior project actually wasn't guitar. My buddy Kirby Hunsinger said, "Hey Eli, you know what you need to make, since you're in the audio? I want a CD player that plays MP3s." So, and I'm like, what is that? And this would have been 1999, 1998, because he was in some other classes a little bit before I did the guitar work. But
wow, he would have liked the MP3 public. My first MP3 player was homemade, but I didn't design it. A bunch of guys got together and made a web page and did what today.
Well, here's the story with Kirby is he introduced me to it because the internet was getting fast enough you could download it. The computers at the time, Winamp could play an MP3 and maybe run one other program, and that's it. Or else it would. And he said, he told me, and I believed him that this was the future. But at the time, there were no chipsets to do this. And so my senior project, I wanted to make something that would decode in real time. And I ended up, I use the term loosely, acquiring the standard at the time was really expensive. And I found out you could use the intra-library loan process to get it, but no one would loan it because of the proprietary nature. But I found one small university who sent it with instructions saying, make sure the student is not allowed to leave. Well, it just so happened I knew who worked at the desk at the library because we were both on the work study program. I'm saying, all right, give it to me. I'm taking it. And I walked out the door, and that was my first foray really, and also into some of this real-time programming. So
I love that. But then from what you learned there, it looks like you landed right into the deep end after that.
Yeah,
right?
and it turned out, and this was one of my first lessons though, that I really wanted to get into DSP, but my first job was involved in power electronics, and I thought, I don't want to do power electronics. This is, boring.
It's where you start. It's like wax on, wax off.
Well, it turned out it was such a ridiculous way of thinking, because the power electronics were doing, they needed a giant DSP front end to do real-time control for these piezoelectric actuators for sonar systems. And
Oh, I've done
and
sonar.
I learned that's where I learned about Class D, and not just Class D, high performance Class D that went beyond the audio band.
Right.
And so my ignorance was pretty quickly cured, and my ridiculous thought about what job I wanted, that it was such a source of growth for me of being into this, because I had to get super in the analog electronics. I was using this TI DSP that just blew my mind. And this, comes the first lesson I kind of learned about what is full stack. It's that trivializing, say, another discipline or another tool is really a bad idea. It's really your source of growth. And I actually did that, in my current work with a lot of, whether it be JavaScript program or front end programming, that trivializing that because I'm doing assembly languages is really a bad idea, because there can be an immense source of, things you can learn, and both sides can kind of bring things to the table that you wouldn't already have.
So you mentioned Class D there, and I'm the same. It's like I went to college for 2 years after high school and got my associates. Actually, it took me more than 2 years to do it. It took me 3 because I also had trouble concentrating then. And I wanted to work and make some money. But I remember being in my the second semester, so second half of the first year, studying the first electronic devices class, and this book you can still get new editions of. It's one of my favorite books by Bogart, Electronic Devices and Circuits. This is the version from 1993, and it's got this whole section on Class D amplifiers.
There it is, yeah.
You see the PWM and the totem pole output stage, and then it's got an actual reference design circuit from one of the semiconductor manufacturers reprinted in it there from the time. The block diagram explaining how the whole thing worked. And I remember we were learning about transistors and power amplifiers in the next year. And I'd read through all of this because I was fascinated by it. I'm like, that's the way. That has to be it. That's the future of audio power amps. And even more, there's more you can do if you can make it fast enough. And I remember asking the teacher in the second year class, why aren't, like, when we were studying and doing all the math for power amplifier design and everything and simulations, and they didn't even mention Class D. I'm like, where's Class D? Where's Class D? What? It's here in the textbook. Why aren't you teaching? This is the future. Like, theoretically, close to 100% efficient. Are you kidding? And the teacher turned his nose up and said, "Oh, you young people, you all like distortion anyway."
Well, it turned
that
out
was his answer. I'm not kidding. I'm like, you asshole, you're wrong about this.
Well, I think part of it does require you to step. You have to think about the circuit and system as a whole. And Class D originally was a little rough just because the switching transistors, the losses weren't that good.
Yeah.
But now, and especially when I started at Cortec in 2000, we had DoD research programs where we got access to the first silicon carbide MOSFETs that were being created they were being created at the University of North Carolina at Durham. And that was a big, and actually Cree Semiconductor is from down around that way. But we literally got these things, the wafers, in these weird gelatinous goo. It was just the weirdest thing ever, and they were hand wired in. And the thought was, like, when my boss at the time, he was explaining it to me, and he showed me all the switching effects. He says, this is the future because the body diode effectively goes away. All your switching losses, it gets so close to ideal. And for our work with the Navy, being able to directly drive kilovolt and multi-kilovolt loads was a big deal, as well as being able to have super fast switching, so you can move from PWM into Sigma Delta based switching patterns to get uber clean transmit waveforms. So yeah, that was my first. That tying those two things together was one of the best things I could possibly have in my career, and it really kind of launched me into what was the next stage in my life. Was at the time I was working a lot of hours, writing a lot of code, doing a lot of stuff, and we were doing a lot of research programs with Penn State University, working with grad students. And then I realized, well, wait a minute, they're getting these fancy degrees. I'm doing the same work they are and more. Why am I not getting this stupid piece of paper? And so Penn State had a degree that really interested me. It's the only graduate degree conferring program in the country in acoustics, the science of sound. And it was, I keep telling people the reason I went there is because they let me in. Maybe I wasn't good enough for a computer science or EE.
You know what?
But
it doesn't matter because you're an insanely good engineer, as your career has proven.
Yeah.
This comes back to the thing, and I say this to my kids too, because there's an awful lot of social pressure to go to a name brand school in this country, and it's kind of ridiculous. And I didn't go to a name brand school, but I tremendously value my education from University of Southern Queensland. And I'll tell you, there's two reasons I went there. One was they gave me the most credit for the work I already did earlier in my associate's program, more than any of the other local universities around Sydney were willing to give. And two, they had, I did some research on the faculty, and they had some, like, my goal was to learn DSP as well. And they had this guy there, John Leese, Professor John Leese, who was just a brilliant instructor and teacher on DSP. And so it made the choice kind of easy for me. So.
Yeah, and for me, like I said, I had been working for a few years. I was out of school. I knew in at Penn College, I took some extra math and whatnot to thinking I would do this, but I won't name the school. But when I was, my oldest child was just born at the time. I was thinking about grad school. I went to a name brand high-end engineering school, and the department said, "You don't belong here. You went to the wrong undergraduate. You're done." And is at that point I said, "F you."
Yeah, exactly.
I'm taking my money because I'm spending. I'm
Oh,
dumping my money somewhere else.
Eli.
Yeah,
they don't understand how this actually works in the real world. Their heads are so far up their own armpits, let's say.
Yeah, no, and maybe he was right. Maybe I did go to the wrong. So I don't know, but I wasn't going to let someone stop me.
No. You ended up teaching back at Penn State, didn't you?
I did, and it wasn't at Penn State where I was told this. It was a school up in New York, but I found the program acoustics, which is it's a quarter mechanical engineers, a quarter physicists, a quarter EEs, and a quarter of ragtag whoever else, biology, speech, human hearing, with pretty much it comes into its physics, but it has an extremely diverse faculty. And there are people doing sonar, DSP, whale communication, sonic booms, structural acoustics and rockets. And it was another thing. I said, I'm going to go here. I'm going to do this. They let me in. I had to work really hard because I was behind on the math, but what I wasn't behind on, I could build circuits, and I got a job working for a professor, and I could get this master's degree done super quick because I was already doing research. I just had to figure out how to do the math. I suffered.
What advice would you give me? Because I did really well in my university degree. I ended up graduating with the first class honors, which is like summa cum laude here in the States. So I did well while I was in it, but afterwards I went and worked for Altium for 16 years and helped them get rich. And I was paid well in the process. So they did take care of me, but no stock or anything. Anyway, let me not go down that road. But when you wind up teaching people PCB design, there's a bit of math, but it's nothing like signal processing or what we did in university for electromagnetics. And for anyone else who's out there, like, what's your recommendation for someone who might be considering going back and doing a a PhD or a master's, or even, I mean, there's no need to do it really, but let's just say I wanted to be good at this. What would you?
Well, I went into this once again with another naive viewpoint that I wanted to combine this with the electronics and PCB design and software to work at a Yamaha, a Roland, Harman Music Group, and this would give me the edge. Well, it turned out the world got much bigger. It's like a UFO landed, and your worldview changes, right? Because I saw so many things. But the one thing after doing it, the master's is a lot of bang for the buck. The PhD, I actually took the candidacy exam. I passed that. I took all the coursework, but just between family life and career, I was working on some research. I decided to shelve it. And I think until my kids are grown up, which is pretty soon. Because I discovered along the way, I got a job at Penn State teaching part-time undergraduate, and I loved it because I taught circuit theory and microcontrollers. I didn't have to write papers. I didn't have to deal with politics. All I had to do was come in and talk about circuits. And it was, what better thing to do? It was true teaching.
That's probably right around the time we met, because I think you were teaching people PCB design with Altium as well.
Yeah,
so
I was in a senior design, but yeah. So the job I actually had after grad school was at the Penn State Applied Research Lab, which is actually a Navy UARC, University Affiliated Research Lab, that focuses on undersea weapons, torpedoes, submarines, some robotics. I joke that every robot design I've ever seen is Johnny Five. Like, I have yet to see a robot in the military that didn't use Johnny Five as the, in other
words, they're all tracks except for Boston Dynamics, where they're. Yeah. Have you seen those funny videos where they mock up? They do. It's not a real Boston Dynamics robot, but they superimpose an animated robot that's getting back at the engineers for all the mystery.
Oh, Corridor Crew did that.
Yeah, you got to check those out.
They had like at the end they had a robot dog, and they told him to shoot the dog, and he looks at the dog, looks at them, looks at the dog, and then attacks the humans. Yeah.
But
the dog's shaking.
Yeah, for me along the way, so I kind of worked in this research lab, and it was pretty hardcore, just embedded systems, electronics, acoustics. It was like a design engineer, probably similar like Dave Jones's story. I think he did the same kind of thing in the Australia, because we did work for the Navy.
Yeah, he was at Thales, which is I think originally a French company, but they're pretty big military contractor for Australia.
But along the way, I did some consulting and worked for a company doing playground electronics. And I still do work with NXP in a couple different forms. I do some work for a company who makes pyrotechnic deployment hardware. So I get to put basically DSP and algorithms and all this stuff. And I think the advice is figure out how to get people to pay you to do the things you want to do anyway. Sometimes it's give and take, but with a little persuasion, I found you can convince almost anyone to kind of bend a little bit towards your direction. If you can say, hey, here's the outcome you want, I will get you that outcome. But to get you that outcome, I'm going to use this chip. But for the grad school thing though, Ben, for me looking at it, the master's is a big bang for the buck. I've had some people ask me in this position coming out of school, waiting a few years. I don't know. I had started a family, and that made it really hard, like obscenely hard. And I had to work a lot of hours just to make ends meet. But having a couple years of context of working in the industry, by the time I went to grad school, I got done faster because once the coursework was over and I had to do the research, I just built everything I need to, and I had it done quickly. I could take data. I know the right code. I could write whatever scripts I need, make circuits to take measurements, and that part of it went quick. And anyone who, and I got another colleague of mine, he's a few years behind me career-wise, same sort of path. when no one else could get a job with any of the professors to pay for it, because he had work experience and could do something, he had multiple offers for his assistantship because he could go on the ship, hook up power amplifiers, build circuits, just do the stuff you need to do the research. And,
right. But he, do they pay all right for that kind of work?
I'll say it's enough that if you don't have expensive habits, you won't die. So for me, the answer is it's enough. Like, it covers tuition and you get a stipend, and as long as you don't have, like, you won't starve and you'll find a place to live. For me, because, you know, married with, at the time, one child, like, the rules are different. I could starve, but I can't expect my kids to starve.
Right.
So,
No, that's right. Yeah.
so I levered.
If I have to eat ramen, that's one thing. But if I have to force the whole family to eat ramen,
I'll say it's not easy, but I was able to lever previous contacts of, like, hey, I'll do some consulting for some companies I used to work for. I worked a lot of hours. I had to become a workaholic to do it,
and that's also bad for family.
It is, and
it wears on children and wives.
It does. And that being said, though, there is always a path, and it doesn't, like I said, some of the students I see, like, graduating at the local university, if you can hold off from making other big life decisions, working a job for a few years and then going to grad school is not a bad way of doing it, because you have context into how other things work, and you have every student on the other side, when I was teaching, who were non-traditional students, were highly motivated and focused. They were there to get this degree, to do this thing, and they just excelled, like, in almost every case. There wasn't a case with a non-traditional student that I didn't see that behavior. So for me,
sorry, I'm just looking. We're at an hour. I don't know where the time goes, but we were talking about full stack as well. So we're building this journey, but you're an EE through and through, but you're also qualified in acoustics, which ties into what you're doing now. So we'll circle back to that real soon. But the whole full stack engineering, we've seen a snippet of that, but there's some curiosity as to what that means, and actually that looks like you'd already tied that in here.
Yeah, and so basically, the full stack developer from the internet and web is basically, you have browser technology, these web frameworks that in rendering technologies like HTML that are underneath of it. But all those things have to make requests to like a back end, and that's where you have web servers and databases and various levels of automation in infrastructure, which is your back end. And when you put those together, that's what is called full stack. Well,
so just a note on that too. That weird company that Altium acquired, that Aram
Morphic,
Morphic. I guess we weren't using the phrase full stack back in 2010, but that was a thing. Like, it started with companies like that, where they would give you one development IDE. It's really an IDE company, and all of this has been replaced by Visual Studio and similar tools now.
One thing that, because I learned a lot of, now I kind of came up with the internet making web pages by directly coding like HTML and doing things manually. But one thing, I don't think if you're coming into this world without that context, I had a hard time, because all of this stuff at the end of the day has to put HTML in a web browser, and however you get there are just a word salad of frameworks and technologies that all do the same thing in different ways.
And there's no good reason to pick one over another.
It's Coke versus Pepsi, and people fight over it. But at the end of the day, like, what you're trying to do is actually fairly simple. How you're doing it can get really complicated. And that's why I think in that world, like, the full stack is just trying to get your arms around it and having an understanding of it. Well, for this product, when I left Penn State with some colleagues about 5 years ago, we, through a very difficult, path. Oh yeah, when I talk about full stack in embedded systems, like, when I in the Altium Live, it always kind of started building up of you have math, you have this ability to do logic, and what I call imagine things in your head spatially is a really important skill. And when you kind of keep stacking those up, that's when you start getting into like field theory, which is really important now in circuit board design, material science, chemistry, sensors. You kind of keep building these up, but in embedded systems, the problem is just like front end development, you have multiple paths. So I initially started on this microprocessor path with tool chains and networks and programming languages, but there are some people who kind of take another path, down like logic design, RTL simulation. The animation, maybe my PowerPoint there isn't quite, but you kind of have these parallel paths that all involved in electronics, but you could very well build your career in just one little subset. So the stack in electronics is tough because a lot of products now, every engineer is expected to do a lot with very little, is having some skill sets in every one of these paths. So you're not saying, hey, I'm the analog guy. That's what I do. No, very few jobs anymore will say, hey, we need an analog person.
Yeah, unless you're in, if you're an RF semiconductor company, then you have that's where the analog guys end up.
Yeah, and I argue there's three of them. The world doesn't need a whole lot of them. You need like three. But even in that world, you have to have a pretty good idea of, for example, almost every communication scheme that actually goes over the air is OFDM in one form or another, which ties into signal processing.
Yeah.
And you have to get down that stack to understand, well, what's my peak to average power? What kind of schemes are these engineers using? And so full stack in the hardware engineering is a lot of different things. But the other thing that really, and this is where I think Scott Adams, who writes the Dilbert cartoon, talks a lot of, is the building a skill stack. And some of these things on here, I think some engineers watching this are like pinching their nose. But the reality is I really wish I would have paid a lot more attention in accounting and economics, because every screw up I had business wise is because I didn't understand something. Sales and marketing are really important.
EI was the one I was constantly, even as a technical expert, the one struggle I had in my career was understanding emotional intelligence and human factors, and knowing when someone's trying to manipulate me and knowing when I'm just being paranoid, and being able to tell the difference was always a struggle.
No, Ben, nobody's trying to manipulate you. No, you're doing good. Just keep doing what you're doing.
I know, but the problem is when they tell you you're not doing good when you really knew you were. And they're gaslighting and doing all the normal narcissistic asshole things.
It's, for me, I look at it as, like Scott has this moist robot filter of like,
yes, I love that.
We're all these moist.
By the way, if anyone's interested in that book,
it's How to Fail at Everything.
How to Fail at Everything and Still Win Big.
He has another one called
his autobiography. It's really good.
Yeah, and there's another one called Loser Think, which is really good.
Yep, I listened to that one on Audible last summer.
But if you think about it, we are soft, wet computers that with the right inputs, we don't necessarily get binary outputs. We get probability distributions of outputs over time.
Right.
And while you can't change luck, you can go from a situation of low odds to high odds. And that's the game.
That's exactly it. I love his analogy from also his how to lose at everything and still win big. He talks about luck and what it means, and it's not this random thing. It's more like, if you're a skilled hunter, you learn that if you want to hunt elk, you're going to study elk. You're going to know where they go seasonally, what their habits are. You're going to learn about their breeding and life cycle, and you're going to learn about what they like to eat. and you're going to learn how to tell, how to track them, and how to tell. And you learn all this stuff, and then you go situate yourself in the right place at the right time, and you may not see any, but you've improved your odds dramatically.
You've shifted that probability distribution curve to a point. It's not going to be every time, but you're better than not doing any of that. So,
and actually, I think learning digital signal processing helps with this too. If you're an engineer, or even if it doesn't matter, a lot of people who are watching this are probably hobbyists and not engineers. That's okay. None of this is beyond you. This is DSP to me, actually. When I had a good teacher, when I went to University of Southern Queensland and had the guy who I knew was a great teacher for it and had written an awesome textbook, and I also got another fantastic book called DAFX, which is a collection of papers from an annual audio signal processing symposium that happens in Europe. By Udo Zolzer. You've probably got the same book, Eli.
Mm-hmm.
DAFX by Udo Zolzer.
Yep.
And these kind of resources, they break it down, and it's actually not that hard. It's.
And I wrote some blogs for NXP a year or two ago on FFTs and digital filters, removing every bit of math. And the FFT I explained with a block of wood, what in a right angle triangle of what it means. And like a lot of these things, the symbols that are used in the language that's used is hard. Almost everyone understands the underlying concepts when presented in a way that relates it to your normal user interface.
You can learn FIR and IIR filters using an Excel spreadsheet, and it's actually way easier. The first FIR filter I ever designed was a 30-day moving average on stocks. Whoa, wait a second, that's an FIR filter.
That's
How about that? Right?
Our instructor at Penn College made us do that before we used MATLAB or toolkits or whatever at the time. We literally went in Excel. He said, you will compute this like an abacus. I want you to see every operation. And that's why even now, because I've been into researching some of these machine learning and AI algorithms, there's this immediate need to go to the latest Python toolkit when I'm like, at the end of the day, this has to be something that breaks down to a system of, now it might be a lot of computations, but they're very simple things, and they're actually very analog in nature of how they work. So, yeah. So,
and you know what's really cool? If you understand this stuff and you've studied it, guess what? You're also a consulting expert who can get paid high hourly rates.
Oh my God, yeah.
To educate people who want to learn day trading.
And if you have the ability to work
Not
with
that I've done that myself, but I just know I've met quite a number of electrical engineers who wound up being in fact, I went to a career fair on behalf of Altium's. This was back in 2011 before I moved back to the States. I went to a career fair on behalf of Altium's HR department at the University of Sydney for a career day. For that, the idea is, you attract senior students or students who are close to graduating or want to start working or do a placement program. And the number one booth that was the busiest was, guess who? A bank. It was Macquarie Bank is probably the biggest corporate bank in Australia. And the guy at the booth was an electrical engineering graduate. And I got chatting with him, and he's like, oh, yeah, we're actually here to recruit electrical engineers.
Right.
The bank was there to recruit electrical engineers. So just...
Have you ever seen the movie Margin Call with Kevin Spacey?
Yes.
Yeah, in there, Quintina, whatever his name is, Zachary.
Yep.
He's like, well, I'm actually this and this. And the guy looks at him and says, so you're a rocket scientist? He goes, well, yeah.
Exactly. But it's
right into the financial.
It's engineers who wind up being the best at that stuff, because you can employ all the stuff you learned in your DSP classes and possibly do it in real time or near to real time.
Yeah, and I use this kind of view of the stack too, just for introspection of saying, like, anytime I'm having trouble with anything, whether it be personal engineering, of just being able to look inward of figuring, okay, I am this moist robot. Why do I feel this way? Why do I have these biases? Why am I thinking this way? And how do I break out of the mental prison I'm in? Because it's the hardest thing in the world to see. But if you can unlock it, there are other people in the world who are not engineers, which are most people. That's the thing they get, is most people are not engineers, and figure out how to interface them with them. It can really help you, because then you can work together and they'll pay you to do things you want to do.
Yeah, Stefan, I wasn't actually really recommending it necessarily. I'm not saying you should join the dark side, but on the other hand, there's nothing wrong with making money for other people. I don't have a problem with that, or with capitalism. I think that model, like Scott Adams says, it has flaws, definitely. We all see the flaws in capitalism, but it's the only model that has really been time tested to, over the long term, actually work. It has problems. We'll work them out, hopefully.
Like all engineering.
The alternatives usually end up in some kind of slavery or death for tens of millions of people.
Well, I mean, some of it too is you can't in any system remove the fact that humans are involved. And the best. Well, the best is forward. Like until, like I said, until the aliens land and teach us something different, we've got to figure it out on our own. And guess what? People are flawed, and it's not necessarily because it's always intentional. We have to learn with all of our flaws, and each of us has our own interface. One of the most brilliant engineers I've ever worked with had the most difficult personal interface, but once you learn it and you learn to work together, you can do a lot of neat things.
Oh yeah, that's the tough thing, like, and this is something that I don't think we have time to go into today, but it's part of this presentation that you gave, and I appreciate it. Is one of the things that we absolutely, it's probably lesson 3, is you can't do all this on your own.
Oh, absolutely not.
And you were talking about fighting the imposter syndrome, which I think a lot of technical people have. I know I've struggled with that
myself as well
over the years. So I think every technical person, whether you're degree qualified or not, like Bill, you are one of the best engineers I've ever known. And you will always be one of the best engineers I've ever known, and probably anyone else who's watching us currently. And we all agree. We just look at what you did with the 128 and all of that, and even what you've done with Hackaday videos and this stream and some of the stuff you're working on today. But you never went and got a degree. You didn't need to. Like but you probably wondered, like, how did I end up here at different times, and dealt with the imposter syndrome back in the day yourself?
Well, yeah, I felt extremely lucky to be there, but then the call to battle was, you fight to stay there. So it was sheer luck I got, hired by Commodore, but I
it wasn't sheer luck.
I stayed working there. Yeah.
I disagree. It was not sheer luck. It was a bit of luck in the Scott Adams sense. Like, you were statistically likely to win that job. You were in the right time, in the right state and location. You were in Jersey. You were in, and you had the right experience up to that point with the 6502 with Industrial Instruments. And that gave you an edge, but you didn't realize it. Sometimes life brings these things to you, right? And Eli, I'm sure you've got a lot of what we've looked at even today are these serendipitous moments that all that passion and engagement you were into this thing, and it led to something. Your interest in music, keyboards and guitar, led to you studying acoustics, which led to what you've done with T0, which is really revolutionary and different. It's actually quite amazing. Measuring beer without having to take samples is pretty profoundly powerful. And I think I think you need to spend more time here in San Diego because this is the microbrewery capital of the world. A, we get to hang out, and B,
Yeah, exactly.
we'll try a bunch of different microbreweries.
See how well they're measuring their beer. Yeah.
Yeah. Well, and
I
it
think
leads.
there's a psychological barrier to get through, which is they probably like doing things the traditional way because that's
Right.
From the business
proud
point of
about
view,
that,
that's well, COVID crushed everyone's business dreams and hopes for selling products when no one wants to make capital expenditures. But yeah, and there is certain art, when you're working with artists definitely like the things like just like guitars and tube amplifiers. People like what they like, right? So,
I have friends here who are professional, or at least have spent much of their careers as professional, like paid guitarists, and they're super purists. But eventually, when it's about tasting the product, right? Eventually, they have to come around to, well, these impulse response doohickeys that line started.
Well, it's something.
I've been double blind A/B tested on them, and I can't tell the difference anymore.
It's interesting too. One thing I did learn too is it especially is like leaving a day job to, work at a startup or whatever, is that there's this and this is something I saw in myself. There's this weird view that, especially in their engineering discipline, that when you look at like business and marketing people and they say, well, they failed at a business, therefore X, Y, and Z. But guess what? How many circuits have you made that didn't work right the first time? All of them.
Oh, yeah.
How many took 18 versions before you got the bodge wire right? All of them. And so in things in like marketing and business, you can have 100% technical success, but you could have a marketing failure, you could have a business failure. And that doesn't mean you're a bad person, right? It doesn't mean you failed. It just means use that failure and mug the crap out of it to learn every
that's
bit.
the Scott Adams principle, right? It's his advice. It's like, I'm not going to accept failure until I've basically, what does he say? I've broken out of the cell.
Oh yeah, it's like
burned down the prison and taken the warden captive.
Yeah, no, I think he went one. He said, break out of the cell, get the other convicts out, burn it down, and shoot the warden.
Release all the other convicts. Shoot
So,
the warden. Yeah,
but
that's how he treats failure. Like it must be a learning experience, and that's honestly something I've really struggled with. I'm determined to do that differently now with what I'm dealing with right now is kind of hairy, but it's going to be that everything is an opportunity to learn something of value to humanity. And if you have something of value to humanity, you can make a living in any market or situation.
Sometimes just knowing too of when you got something and when an opportunity is there, it doesn't need to be perfect. The conditions don't need to be, well, I didn't get 100% of what I wanted. Well, like from the political point now, I don't know how many listeners will remember this, and whether you agree with his politics or not, Ronald Reagan had the best statement, and maybe he stole it from someone. Someone agrees with you 60% of the time is not your enemy. That's actually a friend. Knowing when you can build coalition and build, in whether it's in a technical sense or a sales and marketing.
And if someone is agreeing with you 100% of the time, you should be
you're being
cautious.
manipulated. Yeah. So,
that's not normal.
If I can get more than 50% of what I want, I won, right? You're a winner, right? So, it doesn't have to be 100. So
this is really fascinating. Tell us all about.
Yeah, I'll try to go quicker so we ran across, and I won't go into the details of the business of how we got there. We got approached of building a sensor to measure fermentation. And so basically beer, you make beer tea. You take grains. I'll simplify it. Say you steep it in water and you make beer. Yeah, you make beer tea. It's sugar water. Yeah, it's sugar water. Well, you take this sugar water, you add yeast. The yeast consume the sugars. They generate alcohol. And that process of fermentation, it's 100% biological and chemistry, right? You got to start with the right stuff to get to the thing you want at the end. And so you have to monitor this fermentation and monitor, and make sure the temperature's okay, and make sure it's progressing the way you think it is. Because the yeast generate a lot of CO2, they generate heat, which can cause themselves to kill themselves. And there's certain metrics you got to hit. Well, the state of the art in fermentation monitoring is hydrometer. It works off a buoyant force principle. You drop a hydrometer in a column of fluid, and you look at a displacement, and you look at a number, and it measures a relative density. And so, in this particular problem, brewers will take these measurements once a day and then kind of track how well, based upon this relative density, am I moving in the right direction? For a small home brewer, it's not a big deal, but if you're trying to make lots and lots of beer consistently, introducing just even a day because something went wrong can be a problem. And so we were approached to say, hey, we have this other system to manage everything else. We just need a way of doing this measurement because there's no real good way of doing it in real time. And so that was somewhat inexpensive. So what we came up with was a probe that could be inserted into a standard fitting on all these.
Forward to it. Sorry.
Yeah, you're getting it.
You already mentioned.
You can just keep going. So
gravity. I've done this because I used to homebrew back in Australia way back before I got my job with Altium. I did it for a while and had a friend who actually got poached by a microbrewery in Sydney. Left his day job forever. It was a big win. But so
if you keep going, so there was
you can measure bubbles somehow.
We do it acoustically.
Do that optically, right?
We do
maybe not.
Yeah, we do it acoustically. So what our novel thing is, myself and the business partner, we all have this acoustics background, so we understand how sound waves move through the fluid, and the fundamental sound speed equation is right there. It's you have temperature and these other constants tied into sound speed. So if you know temperature really well, and you can measure that sound speed, you can pull out these other constants. Well, if you click one or two more, it turns out they're related to two things: this bulk modulus of a fluid, which is like a spring stiffness, and a density, where we could get a density if we could take these other measurements with enough precision. And so we built a probe that, with the idea is, it has to be super easy to install. Relatively inexpensive, and easy to use. And it actually turned out those constraints were a bigger deal than anything else. But you don't end up with a whole lot of ways of measuring the fluid that you can put something in 10 seconds, have an installation, and be done. So our probe is designed to go in this tri-clamp fitting, which is a compression fitting that is on almost all tanks in the food and beverage industry. It's in everything from wine, cheese, milk, whatever's in a tank. So we built this sensor that could kind of...
Cheese in a tank just sounds wrong to me, but okay.
Well, it doesn't start as cheese.
It starts out as a liquid, so it's okay.
And that's a picture of on the side where it's black and gold. That's where fluid is. The tri-clamp fitting is on the other side. So we have this probe that we could just put in the fluid.
That's so cool.
Yeah, we got the little animated GIF there of the probe. So everything that touches the fluid is food and beverage rated stainless steel. Yeah, which is a big deal. So
been there, done that.
This could be used for all sorts of things, not just beer.
And we'll get to that as part of some. Once again, the business. There was the technical success and the business failure of the technical success of making the probe. It's just we released it right when the world went to hell and no one could go to restaurants or breweries. So, and it's just we couldn't control it, right? You can't control when bad things happen.
But this product is still available if people want to start using it now, because everybody's back at brewing for sure.
Yeah, so we went down a path when we saw that we just couldn't get to the sales numbers, that the value wasn't there at the time of what other fluids can we measure. And it turns out we got into the HVAC in the food and beverage industry of when they want to look at different coolants and efficiency of heat exchangers. And imagine, and we found a specific problem in pasteurizers, that these pasteurizers who move lots of, we're currently actually working with Hershey chocolate with some of our sensors. It's a little bit different design, but they move mountains of chocolate syrup through pasteurizers.
Wow.
And every minute of downtime is huge. And when these things need serviced,
That's huge. Yeah.
It costs a lot of money. So
just for those who don't know, a pasteurizer is a big tank
boiler.
Basically takes some consumable and heats it or superheats it to kill any germs or other bacteria or other nasties that may be in it, right?
Yep.
And then you cool it down and then you can repackage it.
Did you say you did that for Hershey?
Yeah, we currently actually have a pilot at Hershey where what we're doing is using other acoustic technology to understand the efficiency of the heat exchanger.
Okay.
Not only through temperature, but through flow-induced vibration. So imagine gallons and gallons of chocolate that we can identify problems with pumps and everything else.
Butter.
Everything. Yeah. And in the service on these things, if we can push out service another 3 months, service might be a $200,000 job. And the ROI is really easy to look at of saying, hey, we'll buy you extra 3 months every 6 months, and you're spending $250K. Well, we're going to put some things on there to tell you when you have to do this or do additional cleaning cycles. Right. So that's where the whole acoustics tie in. And the tie-in for us is we do everything with cellular technology. So we can deploy our sensors without having to touch the customer's network, which is huge. Don't ever think you're walking into any enterprise and saying, here's my little bullshit ESP32. I'm going to hook up to your Wi-Fi. It doesn't happen. I'm sorry to tell you that.
They won't even let you take pictures while you're in there, let alone.
Yeah, like you're not bringing an Ethernet cord to plug into a switch. And if you, we've seen other businesses fail because they said, oh, we'll just ask for a VLAN connection and we'll VPN in. Guess what? 6 months later, when you get the approvals, your business has failed. So we use, but walking in with a thing to say, hey, we beam out on a parallel network. It's encrypted. You have access to the data. Everyone loves it.
Was it Zigbee or something like that?
What's that?
Like Zigbee type communication?
Yeah, so we use a newer technology called Cat M1, which is a newer cellular. It's part of 4G LTE, but it's for sensors. It's a low data rate. It can be battery powered.
Right. And
there's another protocol called NB-IoT that operates in its own bands. It actually penetrates deeper into facilities. It's pretty cheap. The modems are super cheap.
So it's a competitor to LoRa, you would say.
So we use a Nordic part. In Nordic, when I was at their first sales presentation before it came out, they said, we believe this will beat LoRa for the simple reason is that there is no such thing as free networking. It doesn't exist. Just because you have it free at one hop in the chain, you still got to get to the internet somewhere.
Yeah.
And our business is built on here's the basic philosophy is any problem worth solving. If we can't justify a few dollars a month in cellular cost, do we have a problem worth solving? Like it's as simple as that.
If you're worried about a few bucks a month in some kind of connectivity cost.
Oh yeah,
you're not in business.
You're not in business.
You're in the hobby world, and you have no startup capital.
I had the CEO of American Shower and Bath call me in to try and get my ISDN price down like $10 a month. American Shower and Bath, the people that are in all the Lowe's and Home Depot.
Oh yeah.
I looked at him and said, you're spending more of that money sitting here talking to me than you're saving. He had like 6 people in a conference room to lower my price $60 a year or something. And I tried to get through that cost of Cost of
So-
doing business.
With our latest sensor, I got one right here. Yeah, I got the cap. This is one side that has the radio in it, the NRF 9160, some accelerometers, temperature sensors. But what's neat is that all this stuff is so well integrated. Yeah, I'll
Show
bring
us
that.
that again.
Yeah,
That's cool.
and actually, I'm going to get the actual raw circuit board here.
By the way, I did a thing for Hershey's too. They were my customer back in the 70s.
Oh, cool.
Yeah.
It smells wonderful. So,
Oh, it does. You can't get near the town without smelling it.
well, in the factory too is when you're producing billions and billions of calories of chocolate, you end up with a lot of waste chocolate that ends in boxes, and you
Right.
walk around and see these giant 4 foot by 4 foot, boxes of just chocolate that didn't make it, and you just want to like scoop your hand in it. And
So
I
I toured the Cadbury factory in Hobart, Tasmania. I think they moved.
oh man,
I think they finally capitulated to global market forces and moved some of the Australasian manufacturing to Southeast Asia. But that's where, and you think Hershey chocolate's okay, but being an Australian and coming from
oh yeah,
they're like Cadbury chocolates. Cadbury chocolate in America is actually Hershey. It's made under it's a branding deal. But it's not the same because it's still Hershey chocolate and it has an additional bittering agent that it's just traditionally American chocolate has that.
Right.
It's not really bad, but it's not quite as smooth. I toured the Cadbury factory. It was the same, but the nice thing was they allowed you at the end of the factory tour, you could go to the cafeteria that employees bought their lunch at, and at the cafeteria you could buy miss molds. So this is where you get a whole slab of chocolate, but one of the little squares maybe has a divot in it. It didn't get through QA inspection.
Right.
And they have it's the same. They have pallets of the stuff, and you can just buy as much as you want dirt cheap.
They actually have rework too. I've talked with people that work in their rework department, which we think of as like painting and stuff. They actually go in and fix chocolate bars and stuff. If there's like an easy way to fix like your Kit Kat bar, things like that, they have chocolate rework stations.
Yeah. So I gorged myself I was 13 years old at the time. So I went nuts with my pocket money and gave myself 2 weeks worth of heartburn from just eating chocolate.
So tying into the full stack too, and you mentioned like lower bill, and the cellular technology is really interesting because we can pack in that Cortex M4 that's in there most of our signal processing, all of this intelligence, connect to a network. But one thing that blew my mind too, like when we had to build the other end of the system, meaning we have to ingest all this data so we can do data processing on it, whether it was for the brewery work or whatnot, that we could do an insane amount of work in the cloud with the algorithms over days and weeks, and then keep the simple stuff out in the sensor. This is the picture showing the full stack. This to me is the full stack.
Yeah, and this is kind of what you're talking about now too, because it's like there are lines between what you're doing in the sensor, and there's so much you can do now just in the sensor. And if you can have really cheap network access because you're using something like LoRa or this new protocol that's low bandwidth, why not? You can put so much value in the end node itself, right?
Well, and here's what we found out too is when we were doing the brewing work, mapping from there was quite a bit of signal processing in the probe to get to 3 or 4 different statistical metrics. But then that's over, say, from picoseconds to a second of time frame, but over hours to days was another time frame to do work. When we were just trying to figure out how to deploy firmware updates to n number of places and keep was a mental load that didn't need to exist. When if we could take that reduced data set, move it into our back end, so deploying an update for say one customer is easy because I can just patch the algorithm that they're using for their brew. So we could do a lot of this R&D and discovery by using the fact that we can move data kind of intelligently.
And you can did you build in a reliable remote firmware update so you could add features to sensors?
Yeah, so
and all that.
This is where I guess my background kind of maybe conflicted a little bit with maybe the software engineering. Is when I think about a project like a sensor, even though we have flash technology and all this way of doing it, write as if you have read-only memory. Use that as your guide of what if you can't? What do you do? What if your cellular thing, it cannot go down? So now that doesn't necessarily keep you from having to do updates, but it changes your mindset to think of how do you engineer things so they don't fail, coupled with when you start getting into the cloud computing and that regime of, at the end of the day, we're moving hundreds of bytes of data. Some of the protocols, the engineering and the software stacks would blow my mind of like, look, guys, we have 100 bytes of data. This should not require a Java virtual machine on top of Cortex A53s on top of it's 100 bytes with, ints and, characters. So now that being said, there is times when you use these higher level data structures and, in engineering principles, certainly, but I feel like when you can stand in any one of these boxes and be able to look in either direction and interface with those people and have good discussions, there's some really neat things you can do, because I can learn a lot from the cloud computing people, and I feel like they can learn a lot from me. So
totally. And their job gets, they get to do something more interesting too. When they're learning more about what's the actual base problem you're trying to solve here.
To answer your other question, the firmware updates came later, and we figured out what is the simplest way to do that's what it comes down to. What is the simplest way? And that's why I've always been, while I use like embedded Linux and those kind of technologies, I've been a microcontroller person because they're so powerful now. And I like thinking about making machines that do one. It doesn't have to solve every problem in the world. It has to measure this thing, provide these outputs, and send this data out. And that's why I've just always been a microcontroller person.
I'm a microcontroller. I don't trust, anything you can't shut off at any second and then turn back on without corruption is desired for me. And that to me is a microcontroller. You can pull power at any time, whereas a Raspberry Pi type thing, it's like, oh, you didn't close the file system.
Yeah, we've interacted with now our business model is not consulting, but we've been interacting with enough customers who've kind of done their own thing that you can make a whole business out of, if you're in consulting, of what I call Raspberry Pi and Arduino rescue. It's really easy to prototype, but the real world will kick your ass that's because once you get to hundreds or thousands of units, that's when you're at the edges of the probability distribution curve of all the weird stuff.
And this is why I recently endured the pain that is the ST Visual Develop workflow with STM8 for another customer, because it's like, we could use an Atmega and prototype this whole thing using the Arduino processing sort of tool chain, and it'll work. But it's going to mean you're buying a chip that costs 8 times as much because it's an Atmel, not an STM8, and also because it will require all that additional flash for the bloat that is Arduino toolchain and libraries.
And I'm also careful to separate out the thing that got me into all of this was BASIC, which is not what you would call a high-end There is a difference between rapid prototyping, getting people interested, but once you get the skills, and if you see the trajectory of where something's going, I always feel that any project requires a fixed amount of energy. You get to move where you put that energy. You're either saving at the front end or the back end, but there's a sum total that is a fixed cost, and you have to decide where you want to do that. And that is the balance of engineering. This is the slide of engineering is incremental. You start from dev boards, scrappy prototypes, patch boards, and one thing
Right.
that I am adamant about, oh yeah, all the probe designs and all the
So
failures.
looks
And
like that's all the different
yeah,
trials.
we had one that corroded in a tank. Oh, it was a disaster. Like it. That story.
Oh,
from the
I've got
I've heard beer
corrosion
is
stories
very
too. Yeah.
Yeah, we well, really quickly, our first one could do acoustics because we could measure sound velocity, we could measure bubble interaction through acoustic scattering, but we also had a conductivity circuit to look at conductivity from 0 to 100 kilohertz. So we could look at all these bands. Well, when I designed the circuit, like everything, design fast, fail hard, our circuit had the tiniest amount of offset on one of the leads of like 100 microvolts of a DC offset. And that was enough. And the salty, sugary brew was enough that when that thing got pulled out, it looked unrecognizable. Like it was incredible.
Wow.
So
I learned that chicken fat, we used to do something for Weaver Chicken in Pennsylvania. And we did a steam washdown application, which would blow chicken fat up into some strain gauges. And that stuff is like acid. 3 days later, it eats right through a strain gauge to the.
I'd imagine it smells wonderful too.
Yeah, it's amazing for cooking French fries.
Yeah.
French fries are best cooked in chicken fat.
That balance though of rapid prototyping versus not, it's a tough one. But like I said, I do a lot of Linux work on our back end, but microcontrollers are like machines. Like they're just these little things.
Machines.
Yeah, I just like it, and I just find them simple. And now, unfortunately, especially with like NXP and ST's product line, the lines are very blurred. Like one of the ones I'm working with now that has an audio DSP, and it's called a crossover processor. It's clocked at 600 megahertz, has 4 megs of RAM, has FFT co-process. It's intense. Like, but from a fundamental theory of embedded systems, I mean, it's got registers. You can open a manual. You can look at the manual and say, this register connects these two things. Turn the bit on and it works. Like it's
right. That's page 1686 of 4200.
Well, and let me tell you a secret. I think I can tell you this. When you look at these manuals, and this is almost all the vendors, and you see 4,000 pages, those are not written by people anymore. Those are auto-generated from Verilog source code. It's almost like a Doxygen type thing where someone writes documentation on the IP. That's why it seems like nothing's cohesive.
Probably two-thirds of it probably even just comes from ARM.
Oh yeah.
Anyway, because it's their comments and auto documentation from their SOC architecture that they licensed out to them.
That's why when you read those big manuals, it's kind of hard to stitch it together because there isn't necessarily they do some, but it's not like one or two people are sitting down writing a cohesive manual. A lot of times learning how to get through that is
you learn more from app notes than
exactly.
Yeah. For that reason. It's like, well, I just have a problem, but it's similar to this one. So if I read this one and see how they did that one, if I see how they implemented Cordic algorithm, then what I'm doing is something kind of similar to a Cordic algorithm.
Yeah.
So maybe I can modify it and it'll just work. Yeah.
There's an old Sesame Street song. If you watch Sesame Street, one of these things looks like the others. Like one of these things is not the same. Like that's what you apply. Like you just, but yeah. So microcontroller has definitely just been a passion because I feel like I can read the manual and figure it out. Like that's and get to there. So we went through a lot of things that didn't work. So and still do. And the other rule, and I'm sure Ben and Bill, you've probably shared this. Anytime I talk about like a new design, the expectation is, and especially when I do consulting of like, you should expect a minimum of 3 revisions before you get to anything that is producible.
Yeah.
A is one,
There it goes.
get it to work. 2 is to fix the problems from the first one, and 3 is if you can afford it, you satisfy
You
any
make it
manufacturing. You know,
The 3 is the silkscreen revision.
but even then, and that's the biggest tip if you're learning circuit board design. Don't sweat make it. No one gets it in one. Even the simplest board. I've screwed up all 3 terminals on a 3-terminal regulator. So, it's okay. You can you can do it over. So
yeah, plan for a second rev is what I tell my customers too. And when we need our second rev, we'll do this.
And I think part of that too is it's just acknowledging the fact that one of the big things that it actually means to be an engineer, and this I remind myself too when I'm tempted to fall into the that imposter syndrome again too. But the primary role of an engineer is to synthesize an idea into a realizable thing, and that involves doing something that hasn't been done before in almost every situation. If you're just rehashing some old thing in a new skin, or there's a bit of that sort of closed loop maintenance stuff going on too, and we do that a lot if we're trying to rebuild a nostalgic thing, for example, but in modern implementation. But even that, you're still doing something. If you're implementing a 6502 in VHDL, you probably have never done that before. So you expect to have difficulty, and you expect to have overruns, and you want to stay optimistic, but you also want to get in the habit of saying, well, however long or however hard this is going to be, we'll probably double or triple that. And that's just going to be normal.
Okay.
I also have one other rule that I'm adamant about, because I worked in a Penn State where in the PCB design, the people who design the footprints aren't necessarily the other engineers doing the layout. I have a rule. The person who makes the footprint is the person staying the weekend to cut and jumper traces. Period.
Yeah.
There's no and that's
I
why
love that.
Because you mess it up once or twice. Now I still make mistakes, and everyone does. But when you put that, ownership, it's that ownership mentality of that's the person that should be responsible, because we have this whole process of what something would be called verified. Hey, it's checked and verified. No, verified is it's soldered on the board. It's gone through reflow. It works after about 200 of them. I'll start to believe, but leave it at that point. But before then, and that is a difference between the software and hardware worlds. About I've seen, just working with other software people saying, well, why doesn't everyone use common libraries and footprints and we do that in software with libraries? And the reality is the pain you feel from a mistake can take months to unwind. So it's just different. So
there's a lot more at stake when you're fixing things in atoms.
Yes,
software. That's where pure software developers. I know when they stop and think about it, of course, everyone understands this concept, but it's easy to take it for granted in your day-to-day work if all you have to do is make a quick update and deploy it.
Run it through the test routine and do your automated testing. But that being said, there are a lot of things from that world that could be brought into the hardware world that I found that are really good design principles of how you test and how you test changes and how you validate that a change is doing or not going to impact other things. And there's definitely disciplines that definitely go both ways. And that's one of the things I've learned, that it's really important to keep your mind open to some of these other ways of thinking. So.
Right.
I really liked this slide too. I wanted to bring this up. I know we already touched on this topic, but I really like the way you depict this, because I don't know, it resonated with me. What you know is actually a bit more than what you think you know.
Yeah,
and
the Venn diagram
what other people know is different and somewhat overlapping, but it's other people don't know everything. So I really like that.
Yeah, and boy, I still fight with it, and it's one of these psychological, it's part of the moist robot problem.
Totally.
That and yeah, scratching other people's backs is, a good thing. Making other people's lives, like I said, in that stack of, if you can look up and down the stack and help the other person, people remember when you help them, and then you make their lives easier, unless you're dealing with a raging narcissist that has serious problems. But the good news is
exist, but
yeah, they do exist.
They're rarer than I think most of us believe.
And once you know that, you can leave, and that's your exit strategy of of learning how to recognize that. And that green thing is finding people that make you feel empowered, that you can do more than you think you can. Because there's been times like, boy, and I'll tell you the story, because it was a big bet for me to go to grad school. My first acoustics class was taught by a teacher, just brilliant guy, brilliant actually engineer as well. I got a 45% on the midterm. And this was after I moved my family, took out student loans, well, I was ready to quit until I didn't realize that was actually one of the highest scores in the class. I didn't bother to check. Just because I thought I did bad doesn't mean it was as bad as I thought. And then, and that teacher was definitely, once he did that, then everyone was built back up. But there was it was the tearing down to build you back up to gaining that confidence.
Did he do that? Was that part of his instruction strategy, or was it just
it was
a mistargeted exam?
No, it was part of his strategy, because he was much more on, I think, he was on a different side of academia, because one of his questions on the candidacy exam, and he gave PhD candidacy exam questions on midterms in your first course for this reason. He was really big into acoustics, oscillators. Well, his question, you had to stand up from the course for your candidacy. He would take a tuning fork. After you've done all this math, he would tap it and ask this question: what is the Q of this oscillator? And he wanted to get you into thinking. He said most people would listen to it saying, well, that what's the time constant? Listen to it, time it, and try to figure out, the decay. All he wanted you to say, it's a really damn big number because it vibrates for about a minute. That's the only. And so he was more about trying to build up those skills of
intuition.
And his questions on the exam weren't purely from do this math problem. They involved you thinking about it. And usually it was a pretty simple answer, but it was very simple. What's the Q of the oscillator? Or does the sound speed go up or down when you add bubbles? I don't need a math equation. Give me your reason why, then back it up if you want to. But if you immediately go to the hardest solution possible, you fail. So, and that's why most people failed, because they were not looking at it in the right way. Then he wanted you to come back and kind of look at the problem differently and don't overcomplicate it. And it was just the best.
Which we all do that.
Oh, I've daily basis. I think I do that. So,
right. Hey guys, look at the time.
Yeah, we're 2 hours in here, so I guess we.
Well, leave it on that one. Leave it on go back the monkey.
Back to the monkey one.
Yeah, this is the other thing I fight with every day, maybe every week. The turd polisher. Mine would be better. I'll do it differently. Not invented here. It's not good enough. Sunken cost. Sometimes when you're halfway up the tree, it doesn't matter. Don't let what you've spent into something affect a future decision, because guess what? Most of the time it doesn't matter. Climb down the tree and get the other coconut. So,
if you can see it's bigger, just go for it.
Yeah, just climb down the tree, go get the other one. So I fight with this a lot.
I fight with that too, because on the other side of that same argument is the don't quit 3 feet from goal from Napoleon Hill. It's the story that this guy, and this is a true story, who bought a mine and actually found gold, but then lost the seam, and kept digging, couldn't pick it back up again. But instead of going and hiring a geologist to understand how can we best find this seam again, they kept going for as long as their willpower held out, and then eventually they gave up and sold the mine cheap to someone else, and they picked up the seam 3 feet away.
And they just got it.
They just stopped a little too early, and so there's that as well. Like, it's know that, like, you can't, like, we have to break out of this thought habit of feeling like I have to solve every darn problem that there is. No, I have to get advice from other people who know more than me. Because
Or if someone else has figured it out, just use it, and you don't have to re-engineer it. Yeah.
On one side, don't go. Climb down and get the other bigger coconut if it's clearly bigger. Also, don't, like, maybe just reach a little further, get that coconut, and then go get the other one too.
So these are things I definitely keep in mind, because like and there's always edge cases, but well, full step.
Really cool.
Yeah,
Thank you so much, Eli.
Yeah, that's my perspective. Good, bad, or indifferent. So
that was brilliant. I mean, we could probably go for 4 hours.
But no, I'm an hour late calling somebody. I got.
I gotta let you go, Bill.
It's not a problem. It's not. No,
it was just a great opportunity to be here and talk to you, and know that I have conversed with someone who's also tied into the Ensoniq branch of technology. So it's
that's brilliant.
Well, we both had something at Hershey's too.
Exactly. There we go.
So I'll tell you what my thing was. I gave him a digital scale that would weigh Hershey's Kisses as integers, right? You'd have 16, 17, or 18 or 19 Hershey's on the
on the count the kisses,
right?
Yeah. Kiss
So
count.
it would adjust the chocolate, but it could have a variable number. So that's how wide the line was back then, was 18. I saw on TV, how chocolate's made, and the line's like 400 wide now or something. And
I saw it the other day. It's incredible.
Yeah, and I did something back when the line was 18 wide.
So you also helped Hershey Company grow, Bill.
Yeah. So excellent.
Cool. Well, thank you so much.
No, and I really appreciate the opportunity, and it was just great talking with you guys.
We'll do this again. There's always more. We'll talk.
Yep.
Maybe next time we'll do some show and tell with different projects and other things we're working on. But that was really cool.
All right,
guys. Yes. Thank you so much.
All right. Have a great holiday weekend here.
Yeah.
All right. Yeah, you too. Everybody be safe this weekend.
Yep.
Excellent.
All right. And well, Bill, good to see you again too.
We'll see you next week, Ben.
Yep. See you then.
All right.